I'm Sherry Lee, and today we're going to learn about when a triangle has three angles that are all 0 degrees. It's certainly not possible in the Euclidean plane, r squared, because a triangle has three sides that are all straight line segments. And in Euclidean space, every point is an ordered pair where both the x-coordinate and y-coordinate are real numbers. It is possible on a surface like this one. This is a hyperbolic surface, and it's hyperbolic because its curvature is negative everywhere. A space has negative curvature when it curves away in two different directions from the tangent plane. So tangent plane is a plane that intersects a surface at only one point and is perpendicular to the surface. And so this heart will have negative curvature right here because part of it is curving upwards and the other part is curving downwards. And a hyperbolic surface is basically a surface that has negative curvature everywhere. And we can model such a surface in a two-dimensional space by just considering where the y value is positive. So basically everything above the x-axis. Okay, and a triangle looks like three line segments joining three distinct non-collinear points. But in the hyperbolic space, which we call this the upper half plane, a triangle looks more like this. This is because of the way we define lines in the hyperbolic space, where a line is actually an arc of a semicircle with its center on this boundary line, and the semicircle is perpendicular to it. And notice that as these semicircles that are perpendicular to the boundary get larger and larger in radius, they start looking more and more like a vertical line. So our second type of line in the hyperbolic plane is just a straight vertical line, which is also known as a semicircle with an infinite radius. Okay, and how can we show that the measure of a triangle here, or the measure of all the angles of a triangle here, is 0 degrees? Well, let's consider a triangle where all three vertices are on this boundary. And so in order to measure each angle of the triangle, it's the same as measuring the angle between two circles, which we get as actually measuring the angle between the tangents of those two circles, like this. So here the angle between these two circles is the angle here, between their tangent lines. And imagine as the circles get in closer and closer so that they only touch at one point. Then the tangent's going to get closer and closer like this till they become the same tangent. And it's going to look like this. And so because the tangents are the same, the angle between them is 0 degrees. And so when you have a triangle with three vertices that are all on this boundary, and the semicircles that create them intersect at one point and share the same tangent, that is when all the angles get closer and closer to 0 degrees. Yay!